from that of other circuits. For this test, we need an ohm meter. Testing should normally be conducted between the neutral conductor of each circuit and all other neutral conductors, and between the active conductors of each circuit and all other active conductors on the same phase. This test relates to switchboard equipment marking and is necessary to prevent unsafe conditions arising from persons handling or working upon energised equipment that could reasonably be expected to be disconnected from the supply. Marking also facilitates safe maintenance and fault finding within the installation. There's a requirement within AS3000 that equipment installed on switchboards be marked to identify the relationship of switches, circuit breakers, fuses, residual current devices, etc. to the various parts of the installation, the corresponding circuit active and neutral connections at terminals of bars, links, circuit breakers, fuses and other equipment, the purpose of certain switches, for example main switches and emergency supply switches, and the main earthing conductor and neutral conductor MEN connection. Marking is normally required on or adjacent to the individual items of equipment. However, the arrangement of equipment may be sufficient to permit reduced marking. In this test, we need the ohm meter. Testing should be conducted between the active and the neutral conductors of each circuit at the switchboard. The circuit will be identified by its typical resistance. It's important that each circuit be tested individually. These tests are usually conducted in conjunction with the other tests. This test is necessary as it's important that the number of points that may be connected to a circuit should be limited to minimise overloading and the subsequent operation of circuit protective devices. This also provides a practical method of determining whether the number of circuits installed is adequate for the intended application. AS3000 requires the number of points to be determined with respect to the type of installation, be it domestic or non-domestic, general or special purpose, the type of circuit, that is socket outlet, lighting points or fixed equipment, the current carrying capacity of circuit cable, and the current rating of the protective device. To check the number of points per circuit, connect a 60-watt lamp or suitable resistor across each light and power circuit in turn at the switchboard. Using the ohm meter, test between active and neutral contacts at each socket outlet and unlamped lamp holder. Then record the number of points per circuit which are identified by the ohm meter indicating the lamp resistance. This test for functional operation is virtually a final resume of preceding tests, which would have normally established that the installation or the portion under test can be safely connected to the supply. Following either permanent or temporary connection to a supply, a check should be conducted to verify, as far as practicable, that the installation operates as required and expected. A visual and operational check should ensure that no open circuit exists in any circuit. Switches operate correctly, particularly two or multiple way switching on lighting circuits. Current ratings of protective devices don't exceed current carrying capacity to the cables. Maximum demands on mains and submains have been correctly determined. Voltage drop has been correctly determined for long or high current circuits. Circuits are connected or arranged for connection to the correct meters and tariffs. Protective devices, particularly the residual current type, operate under fault conditions. And that wiring and equipment is not damaged or installed in positions likely to be damaged without adequate mechanical protection. Well, we've now demonstrated how the tests can be performed when supply is not available. If supply is available, tests such as polarity, transposition of the neutral and earthing conductors, and interconnection of conductors of different circuits can be carried out. Firstly, the test for polarity, for which we'll need test lamps. To test the lamp holder or luminaire, one probe of the test lamp is connected to a known earth, and the other is connected to the load side of the control switch. The correct polarity is indicated by a normal glow of the test lamps when the switch is closed. To test a socket outlet, the test lamps are connected in turn between active and neutral, active and earth, and neutral and earth. With the switch on, and then with the switch off. Correct polarity is indicated when the switch is on if there's a normal glow between active and neutral and active and earth, with no glow between neutral and earth. When the switch is off, there should be no glow between active and neutral, active and earth, or neutral and earth. Transposition of the neutral and earthing conductors in socket outlet circuits can be tested using test lamps and a 15-watt lamp. Firstly, the neutral conductor of the circuit being tested is disconnected at the neutral link. A 15-watt lamp is then connected between the neutral conductor and the neutral link. The test lamps are then connected active to neutral and then active to earth. Correct polarity is indicated by a dull glow when connected active to neutral and a normal glow when connected active to earth. In the case of lighting circuits, the neutral conductor of the circuit being tested is disconnected from the neutral link. A fluorescent lamp starter is then connected between the neutral conductor and the neutral link, after which a 15-watt lamp is inserted into each lamp holder in turn. Correct polarity is indicated by the lamp flashing. Interconnection of conductors of different circuits can be tested using test lamps and a 15-watt lamp. As in the test for transposition of the neutral conductor and earthing conductor, the neutral conductor of the circuit being tested is disconnected from the neutral link. A 15-watt lamp is then connected between the neutral conductor and the neutral link. A correct connection will be indicated by a dull glow when the test lamps are connected between active and neutral. When carrying out these tests with supply connected, steps must be taken to ensure that RCDs do not trip. For detailed information on these procedures, you should refer to the testing guidelines document. Well, that ends the first section dealing with the 9 mandatory tests. In order to ensure that all required tests are carried out, it's recommended that the sequence of testing should follow this flowchart. Just as with the test methods, a complete domestic installation has been selected. Each test is only covered briefly, and all alternative methods and equipment aren't shown as they were detailed in the first section. Now let's look at the flowchart in detail. Regardless of whether supply is available or not available, the preparation should be the same. First, disconnect the supply. Then disconnect the MEN connection and the water heater earth. Now test all circuits for earthing as in test A. When all points required to be earthed have been tested, reconnect the water heater earthing conductor. Before commencing insulation resistance tests, ensure that all lighting circuit switches are closed and appliances are removed from general purpose outlets. Then test all circuits individually for insulation resistance as in test B. Remember that if multi-way switching is used in lighting circuits, these switches should be operated during the test to ensure that all conductors are effectively tested. Test now for short circuit between conductors as in test E. In this test, an ohm meter should be used rather than an insulation resistance tester, which could cause damage to electronic devices such as lamp dimmers and fan speed controllers. Circuit interconnection is now tested as in test F, using an ohm meter to test between the neutral conductor of each circuit and all other neutral conductors, and between the active conductor of each circuit and all other active conductors on the same phase. Neutral earth transpositions for circuits with connected loads such as water heaters, luminaires and ranges should now be tested as in test D. In this test, correct connection has been made when load resistance is measured between active and neutral, and an open circuit is indicated when testing between active and earth and neutral and earth. To test for neutral earth transposition on socket outlets, the neutral conductor of the final sub-circuit being tested is disconnected from the neutral link, and a 60-watt lamp is connected between the conductor and the neutral link. With one lead of the ohm meter connected to a known earth, the other lead is connected in turn to the neutral and earth contacts at the outlet. Correct neutral earth connection is proved when neutral to earth indicates lamp resistance and earth to earth indicates a short circuit. Circuits consisting of lamp holders can also be tested by this method. Circuit marking, test G, is generally checked in conjunction with test D, neutral earth transposition. Now reconnect the MEN connection. To test for polarity in socket outlet and lighting circuits, the neutral load is connected as in test D, and a temporary connection made between earth and the load side of the final sub-circuit's open fuse or circuit breaker. Correct polarity will be proved when, with the switch on, active to earth indicates a short circuit and neutral to earth indicates load resistance. And with the switch off, active to earth indicates an open circuit and neutral to earth indicates load resistance. In the case of fixed appliances, such as ranges and water heaters, polarity is tested by connecting an ohm meter between a known earth and the active and neutral terminals of the appliance, firstly with the switch on and then off. Correct polarity is proved if, with the switch on, active to earth indicates a typical resistance of 5 to 15 ohms, while neutral to earth indicates a short circuit. With switches off, active to earth should be an open circuit and neutral to earth a short circuit. The number of points connected to each lighting and socket outlet circuit is now determined as in test H. A comprehensive functional operation test cannot be carried out if supply is not available. But after completing the tests which have been outlined, the installation can normally be safely connected to the supply. If supply is available, test D, neutral earth transposition, and test C, polarity, can be tested using test lamps as demonstrated in part 1. After completing all tests, disconnect the test equipment. Then, check switchboard wiring and equipment and the earthing system to ensure that there will be no hazard when supply is permanently connected. Finally, complete the notification of electrical work form. This form's in triplicate, and you're required to submit 1 copy to the supply authority, 1 copy to the customer, and retain 1 copy for yourself for a period of 2 years. The correct active-neutral connection of submain conductors is vital for the safety of an installation. AS 3000 recommends and, in situations regarding consumers' mains, requires that active and neutral conductors be identified by different colours. While this practice should reduce the likelihood of incorrect connection, polarity testing to ensure proper active and neutral relationships in submains is still considered to be essential. We'll first demonstrate the testing of submains which incorporate an earthing conductor. Disconnect supply at the origin of the submains, usually by opening the protective devices at the supply switchboard. Prove that the exposed metal enclosure of the distribution board is dead with a neon test probe. Disconnect the outgoing circuit active conductors, usually by opening the protective devices. Before testing, check that your test lamps are in operating condition. When the test is complete, check your test lamps again. Prove that the live parts of the distribution board are dead with test lamps from active to neutral and active to earth. Disconnect the submain neutral conductor from the distribution board neutral link. This removes any connection between the neutral conductor and any outgoing circuit and earth which would confuse testing. Connect 1 ohm meter lead to the earthing conductor and the other ohm meter lead in turn to the neutral and active conductors. Neutral to earth should indicate a short circuit and active to earth should indicate an open circuit. Test the insulation resistance of the submain active conductor or conductors at both the distribution board and supply switchboard. While this test may have been performed during testing of the supply switchboard, a high resistance measurement at both switchboards would establish that the conductor is not connected to earth and is therefore not a neutral conductor. Disconnect the submain neutral conductor from the supply switchboard neutral link. Test the insulation resistance of the conductor. Reconnect the submain neutral conductor to the neutral links at the supply switchboard and distribution board. Now for submains which do not incorporate an earthing conductor. Disconnect supply at the origin of the submains, again by opening the protective devices at the supply switchboard. Prove that the exposed metal enclosure of the distribution board is dead with a neon test probe. Disconnect the outgoing circuit active conductors, usually by opening the protective devices. Again, ensure that your lamps are working correctly before and after the test. Prove that the live parts of the distribution board are dead with test lamps from active to neutral and active to earth. Disconnect the sub-main neutral conductor and the main earthing conductor from the distribution board neutral link MEN connection. Connect one ohm meter lead to the main earthing conductor at the distribution board and the other ohm meter lead in turn to the neutral and active conductors. Neutral to earth should indicate a short circuit and active to earth should indicate an open circuit. However, as the neutral to earth resistance depends upon the earth resistance back to the supply switchboard, it may be necessary to select a higher resistance range or even use the 500 volt range of the insulation resistance tester to verify the connection between the neutral conductor and the earthing system. Test the insulation resistance of the sub-main active conductors. A high resistance will establish that the conductor is not connected to earth and is therefore not a neutral conductor. Disconnect the sub-main neutral conductor from the supply switchboard neutral link. Test the insulation resistance of the conductor. Reconnect the sub-main neutral conductor to the neutral link at the supply switchboard and distribution board. Reconnect the main earthing conductor to the distribution board neutral link. Well, that's it. Having just seen this video, it may seem there's an awful lot to know, but really, it's not all that complicated. With the knowledge of electrical circuitry that you already have as a practicing electrician, it's really a matter of organising yourself and conducting the tests in a logical sequence. Flowchart's a great help here. It can save you both time and energy. The new regulations come into force on the 1st of January 93. Somebody has to test and certify your work, and naturally it's more convenient and economical if you do it yourself. It's a very responsible task.